This question addresses all the important considerations dealing with pyramids, volumes, and surface areas. Please take a minute to read it. So basically we're asked to find the volume and total surface area including the base of such a pyramid. So let's label this diagram a little more clearly. We'll have corners A, B, C, D, a vertex of E, and an X dead in the center. We know that the sides of the square are 18 feet and that the poles themselves are 15 feet, each of them. Now the problem is we don't know the vertical height, the vertical height of the pyramid to work out the volume, and we don't actually know the altitude of the triangular face to work out the surface area. So really we need to think about exactly what this particular triangle looks like. And of course, if you think about it, what we'll have is an isosceles triangle with sides 15 and 15 and a base of 18. And what we need to work out the surface area of the triangular face is this altitude. Because it's isosceles, it means that it bisects the base directly in half, so that is 9. So what we actually have is a Pythagorean triangle with 9 in the half base and 15 on the hypotenuse. So we can now work out the vertical height, the altitude of this triangle. By Pythagoras, 15 squared is equal to 9 squared plus the height squared. So 225 is equal to 81 plus the height squared. So the height squared is 144, and so the height is 12. So the vertical height of this triangle is 12 feet. The area of one triangle is half times the base times the height, which is a half times 18 times 12. So the area of one triangular face is 108 square feet. But of course that's just one triangular face. So I need 4 triangles plus the base. Well, the 4 triangles will be 4 times 108, and then the base is a square of side 18. So the answer is 756 square feet. The second part of the question was to determine the volume of the whole shelter, and for the volume is 1/3 times the base area times by the perpendicular height. Well, we know the base area, that's just 18 squared. The perpendicular height corresponds to the actual altitude of the top of the pyramid above the base. Well, we already know the altitude of the triangular face, and we already have figured out that that was 12. So we can see another triangle in here. So we've got the distance from the center to the edge, the 12 down the triangular face, and what's left is the vertical height of the pyramid. So what we need now is, we know that's 12, we know that's the height, but we don't know what that is. And how far is it from X to the edge? Well, it's halfway across, so that also is 9. Nearly the same numbers as before, but not quite. 12 squared is equal to 9 squared plus the height squared. 144 is equal to 81 plus the height squared. So the height squared is 63. Therefore the height is the square root of 63, which is a bit less than 8, which is 7.94 feet, and therefore the volume is 1/3 times 18 times 18, which is the base, times by 7.94, which gives a final answer of 857 cubic feet. So again, the important part of this question was really to recognize that what we needed for the area of the triangular faces was the height of each triangle, and that the volume of the pyramid was the altitude of the vertex above the base. They are different, so please be careful.